Hi students, welcome to the video lectures of software engineering. Today we are going to talk about system engineering. So what is system engineering and why is it needed? What is the importance of understanding the system engineering? We'll try to know now. Okay. So before we get into building any software, so there is something which is very important, which we need to understand. Like most of the times, the software we create doesn't work alone. Okay. So it is a part of a bigger system actually to say. So, and when I say that it's a part of a bigger system, for example, you take an example of a software for a hospital which you have built. That means it's a application, and an application or the software that you built doesn't work alone, right? It's a part of a bigger system. That means it has to work with the patient monitors, billing systems, or the scanners or the printers, whatever the device, and also some kind of internal processes of the hospital. All these things has to work along with your application. So if we just focus only on a software, so we might miss the bigger picture. So we need a method to understand the entire system first. Okay. So then what it needs is how the parts are connected and how they should work together. Like as I said just now about the patient monitors or billing systems or even the scanners or anything. Okay. And such, looking at this in this particular view itself is called as system engineering. Okay. So the method is called as system engineering. So system engineering will, it tries to help us plan everything actually. So either the hardware or the software or the networking or the business processes, and the list goes on. So that everything, will work properly, and we ensure that nothing is being missed. Okay. So without system engineering, even if your software is perfect, it might fail in the real time because it does not fit into the full system. Okay, so basically, what does system engineering ensures us is to think bigger. Okay, so to think bigger before we start, thinking small. Okay, so you have to remember that the software that whatever we are trying to create is not working alone. Okay, you have to imagine, you have to think that it's a part of a bigger system. Clear. So now under system engineering, we have a couple of things to discuss. So first one is about computer-based systems. So what are these computer-based systems, and what are these software, hardware, people, database, documentation, procedures, and all this? So let's try to go a little deeper into the topic now. So what is this computer-based system basically? So it is just a system, okay, where computers are major part of working. Right. So when I say computer, the word computer, it is not just a simple single word computer, but it's a combination of, or it includes various things like the databases, the networks, the hardware devices and softwares, and even the people who are using it. Everything falls under this computer-based systems. So to understand this better, let us take an example of an ATM machine. So ATM machine is a computer-based system, and as we all know that there's a computer inside it, and also it has a ATM card reader which we put into it, and it has also a cash dispenser to withdraw the cash sometimes, and it has to connect to a network of the bank, and also to the customers using it, right? So whenever we are developing software, so we must understand that it will fit into, or it will sit into a larger computer based system. So it is not just running a standalone, or it's not just running our own laptop kind of thing. Okay, that is what's a computer based system is. Clear. So when I say computer based system, we understood it's there are a lot of things which falls as a part of it. First one is software. So the programs, the files, the data structures, and all these things will fall under the category of software. So the software can be anything. For example, for accounts or accounting software, Tally can be the best example, and you can consider any example that you wish. Then when we say hardware, it's the physical devices that process the data, and example can be your servers, or any kind of a router or a printer or etc. And next point is people. So people is nothing but the user or the customer or the operator, whoever is using the system is termed to be under the people. Okay, so just we took an example of ATM machine, and the customer of that particular bank can be people using it. Then the database is nothing but the kind of structure storage of the data. Then it's documentation, the manuals or the help guides, all these things will fall under this documentation category. And next is procedures. So procedures are the steps and the rules, that governs the entire system, or the procedures. Fine. And to make people understand then what is this procedure, let us say there is a hospital billing management system, or a school management system, or a college management system, so any application that exists. Okay, and the procedure is, let us say for example, there are some couple of steps we have taken under this procedure, that every Saturday or every Friday a backup of the data has to be taken, right? So such things are considered under this procedures. So next we talk about the system engineering hierarchy. So now, how do we organize such a big system when which we had discussed just now? So our software alone doesn't work; it's a part of a very bigger system, as I told you earlier. So now, it is the time to understand how do we organize such a big system. So we use something called as this system engineering hierarchy. So what it does is it tries to break the bigger problem into a smaller or some manageable chunks or pieces. So at the top, we have the entire system that we term to be the world view. I'll explain you what are these views that are mentioned here also. So, and here you can see this is the top, okay, and we just consider it, okay, as a system, entire system, and below what we are trying to do is that we break into some subsystems like hardware, software, networking, etc. So again, the each subsystem is again broken into smaller subsystems. Okay, so this kind of hierarchy will help the teams to work and manage parallelly. Okay, and I'll just tell you what are these views first of all. So considering first thing is world view, as I told you, this particular system engineering hierarchy, so is all about organizing a big system. Okay, it's like breaking of a very bigger problem into small chunks. Okay, so first one is worldview. So worldview is trying to understand the entire business or environment into worldview. And domain view is nothing but to focus on a particular area or particular domain. Okay, element view is nothing but it identifies the major components and subsystems, whereas technical view is to design and develop the technical components. So for example, to understand a little easier, so we'll try to compare this views with an example. So let us say if there is a top view, that is your world view. So we consider the example of railway ticketing system. Okay, so for our national railways, we have a ticketing system. Okay, so the ticketing system is under your worldview right now, and of course that system will have all the things, the stations, the passengers, and various operations. Okay, and under domain view, the reservation and scheduling, all these things will fall under the domain view. Okay, like reservation, scheduling, domain, all under your rail system. An element view is the ticketing module, payment gateway, notification system. All these things fall under element view. And the technical view, just writing the code for the payment API, or designing the database, all these things under the technical view. Clear? So this is what your hierarchy. So what is the purpose of maintaining this is, just now, if as we have gone through all these things now, for world view, domain view, element view, detail view, so like it's just trying to break the big problem into easy, small chunks and manageable thing, right? So by which ensuring that the system is built with a complete understanding in context, and also tries to, this breaking of the bigger thing into smaller manageable chunks is making the system a simple one from a complex thing, right? And yeah, we'll see the next one. Element. Next is the business process engineering. So what is business process engineering? Okay, we'll try to see. So when we talk about business process engineering, the term business is a key thing here. So you might ask me, like, what about the way a business runs when you see this, right? So before we build such a big system, so just we need to understand sometimes, even how the business actually works, right? And this understanding the nature of how business works itself is your business process engineering. Suppose, let us say, if we are building a software for an online shopping company, so we first need to understand how orders, payments, or shipping, or customer support system, all these things will work. So sometimes we find that the business process itself needs fixing before building the system. So otherwise what happens, the software will automate a broken process, right? So that is what we need to understand about the business process engineering. So here also you can see there are a couple of views which are mentioned as the enterprise at the information strategy planning. That is the world view we say, and then you have a business area analysis, domain view. Then again it's broken down into business system design, that is element view, and construction and integration is another view. Okay. So now, the way the business works, or this business process hierarchy, can be explained as, it's like, let's take a real time example. Now, there is an insurance company, and the insurance company generally, the customer asks for a claim for some insurance, and for that, there will be a person allotted, and he or she will be collecting the documents manually, and they'll scrutinize them, and there is a process. There's a manual process which was involved, or which is involved in the claiming issues or some other issues. But now, once this business process engineering is introduced, all the manual claims processing, shifted to digital portal, where the users are being allowed to, submit or track or manage their claims online. So that is how business process engineering works. Okay, so the main goal of the business process engineering is to improve the efficiency and performance of the software, or the entire business, to say, no, not a particular software, and also to eliminate the unnecessary steps. And as of today, the main objective of this business processing engineering is to support the digital transformation. So that is being the key goal of the BPE, that is your business process engineering. Okay, so there are a couple of key components in this business process engineering. We term them as data architecture, application architecture, and technology architecture. So data architecture will organize the business data. Application architecture will describe the software needed, and the technology infrastructure will, supports the data and applications. So as you see now, there are some strategy which is mentioned it from the top level to the bottom. First one is information strategy planning, ISP we say. So this just set business goals, and it tries to define the strategy. For example, let us say there is an e-commerce company, or there is some XYZ company. So now it is trying to, expand its sales. Okay. So that is what the information strategy planning is. And next is business area analysis, BAA. So now what it does is it just focuses on some individual department. Now you can see a business area. So there is one thing which is focused on, right? So for example, let us talk about the business of sales, just we had discussed. So it just tries to analyze the sales or supply chain and some customer service departments. All these things falls under your business, right? So in this business area analysis, it just tries to extract the details, or it just tries to analyze only one at a time. That means it focuses on individual department. So next is application engineering. Okay, the next part what you're viewing. So where we develop the software for the business. Then it is construction and delivery. The last one is where we try to build and deploy the software using some tools. Okay, so the real-time example can be, just we had discussed, insurance company which used to have a manual process, shifting to some digital transformation. That is, a customer can easily submit, or track, and also he can manage the claims online. So that is what the update, for what we that is what the goal of BP. And next, it's product engineering. Let us talk about product engineering. So the product engineering is nothing but, it tries to transform the customer needs into a fully functional product. That is what is product engineering. Okay, so once we know the business process engineering, or the earlier we had the discussion, right? So once we know that business process, so we actually start designing the product, since we already have a clear idea or a picture of how our business is going to run and what sort of software is exactly needed, right? So now once we know the process, we just start designing the product and the system, the hardware, software, everything. Okay. So basically, this product engineering primarily focuses on building the actual solution. Okay. Like the design, quality, cost, performance, user experience, all these things are considered, right? So this is a structure where you can see right now on the screen. So this to have the same, the world view, domain view, element view, and detailed view, right? So now what happens in product engineering? So it is complete process of designing and developing the and also delivering the product. Okay, and the product, when I say, it all includes all the software, hardware, data, users, everything. And now the components, what does it have? So you can see that there's a software, there's a hardware, there's a data, people, everything. So the software is the core functionality, and for example, the code for the application. Hardware is the physical components, whatever required. So since we had a discussion of railway, I mean ATM sometimes, and also some kiosks, some smart kiosks which we use in railways or bus stations. That is all about your physical components, which is covered in the hardware. Then the data part, the input or output, which is handled by the product, and the people are the customers or the users who use it. Okay, so that is about your product engineering. Okay. So thank you, students.